Hi, and welcome back to LangChain Zero to Hero, an unofficial tutorial series teaching you everything you need to know about the LangChain tech stack to get started with your own generative AI projects. In today's episode, we're going to upgrade our API from writing jokes to sharing facts as we learn the basics of Retrieval Augmented Generation. We're also going to take a quick look at the OpenAI Moderation API and explore a feature of LangSmith we didn't cover last episode, the annotation queue. As always, remember that you can find the prerequisite code for this episode on GitHub. Simply head to the releases page and click Episode 3 RAG. Now, before we dive into the code, let's get a brief overview of what RAG really means. When we train LLMs, their internal knowledge is created from whatever training data we use. This data will be at best up to date with the present day, but our model doesn't have any knowledge of events that occur after the training set was completed. Retrieval Augmented Generation allows us to introduce fresh knowledge to our LLM so that it can answer new questions. LangChain helps us connect all sorts of knowledge sources to our LLM, for instance Wikipedia articles, Google search results, or custom files from vector stores such as FAISS. To explain that new terminology, a vector store is a collection of documents which we can search using other documents, or text, or images as the search query. Via a process called embedding, we can find documents with a high degree of similarity to our search. This process is extremely similar conceptually to how Google delivers you relevant search results when you use their site. With all that covered, let's finally take a look at some code. Our first task today is fixing a minor mistake from episode 1. When we set up our LangServe project, we cloned our pirate component into the packages directory of the LangServe project, with the intention it would magically update when we updated the real component. Sadly, for local development, LangServe does not support this feature yet. This means our LangServe API will not update when we upgrade our chain today. Thankfully, the fix is super simple. We can use the command line and then update 3 files in our package component. Whilst we're here, we're also going to take this opportunity to rename some of our project files. When renaming components, take care to update their references. This can include imports in our tests, or LangServe server Python files, or in Poetry PyProject.toml files. This is purely optional, but as our project has gotten a bit nested now, using descriptive file names will help avoid confusion and make the file structure more readable. Opening a terminal inside our LangServe app, the first step is actually going to be removing the MyApp package from our LangServe project. We can do this using LangChain app remove and then the name of our component, MyApp. Removing this, you'll note that in our packages directory, it's now empty except for the README file. What we now need to do is move into our packages directory and actually create a new template. Now, when we're creating a new template, for the purpose of this tutorial, or for the good luck of this tutorial, it's actually going to create a component identical to the one that we've been working with. However, MyApp is quite generic as a term for a component, and so therefore I'm going to rename this Pirate Assistant. Now that we've created our new app, there's a few things that we need to do. The first is to go into chain.py of our real component, copy the contents, and then go into our freshly created Pirate Assistant component chain.py. You'll recognize this from episode 0, and replace it with the code that we've been writing over the past few episodes. Whilst we're in the Pirate component, remember to go into init.py and delete the contents of this file. Now, go into our tests folder and copy testchain.py. You'll notice that there's actually an import here, which we're going to have to update in a second. Moving into tests, create a new file, remember to use the test underscore prefix in order for PyTest to pick up your tests in the future, and copy in the contents. Now remember I mentioned that import. My app is not actually, won't exist once we remove it from our project in the favour of developing from the LangSmith project. So what we need to do is rename this Finally, now that we've updated both of these files, what we're going to want to do is back out of the packages directory and run this magic command pip install -e packages pirate assistant. What this does is it installs a package or a Python module of our pirate assistant component and mirroring it. This will now mean that our app and server file, once we update it, because again, look to see that we're using the myapp import, which is incorrect. But if we change it to Pirate Assistant, it will now be recognized when we run it as a properly installed Python module. We can also go ahead and rename some other references to my app. The only other thing that we're going to want to remember to do is to pip install LangChain hub. This is important since we're using the LangChain hub dependency in order to import our prompt template from the LangChain hub in LangSmith, as per the previous episode. Now that we've done all of this, we can test that everything is working by typing langserve or LangChain serve. If you've set everything up correctly, then the server should boot and start to run. At this point, we can change back into our playground. Make sure if you had the playground open from a previous episode that you are now using the /pirate as opposed to the /myapp file path. And you should be able to load the playground and give it a test. There we go. Now that this is working, we can move on with the rest of the episode. One further addendum that also may be useful. Going back into our Visual Studio project, you can now delete the myapp component, since all further development will be done from the LangServe project. Let's get started with Retrieval Augmented Generation. The very first thing you're going to need to do is pip install a couple more dependencies for your project. These are FAISS CPU and TickToken. FAISS is developed by Meta and is an open source vector store, and TickToken is a package used by the OpenAI API for embeddings. Now, once these have been installed, let's tidy up our terminal and switch on over to chain.py. As we left it in the last episode, this is a very simple chain. We're importing the chat OpenAI dependency and the LangChain hub. We are importing our prompt from the prompt hub, and we are getting our model and defining it as chat OpenAI. We're then creating our chain. The first thing that we're going to do is add in a few more dependencies. Going to paste these in here, and then we're going to go through each one. The first is the OpenAI embeddings, which is the function we're going to call to embed our knowledge. Today we're going to be working with pirate facts, so our LLM will be able to give us some interesting pirate facts to talk about. The next is an output parser, which will be part of our chain, which we'll go into later. The runnable pass-through, which will also be part of the LangChain expression language and part of our chain. And then FAISS, which, as I just explained, is a vector store. Now, the next part that we're going to need is our actual pirate facts. Now, I'm going to paste this in, and it's going to be very dense, but let's go through one or two of the interesting ones. This is very simple. It's just a list of strings. What we're going to be doing today is working with strings, but you could very easily be loading your own text. You could do this from PDFs, HTML files, or any kind of document. You see this being used in companies all the time to generate chatbots which have knowledge of internal Notion documents or other such information. However, I would wager that you should check your security policy before trying to do this at work. One of these interesting facts might be about women pirates, for instance, which are described as relatively rare, but apparently quite successful. Two notable examples, according to this fact sheet, are Anne Bonny and Mary Read. We're going to collapse these pirate facts down, which is just another feature of Visual Studio Code. The code still exists here, we can just hide it away so that it's a little bit easier for us to read. And then we're going to want to define our vector store. We're going to want to take all of these facts and embed them into a vector store. Now, here's the snippet that lets us do it. Using FAISS, we're able to compile a vector store from a list of texts. In this case, our list of texts, our list of strings, are our pirate facts, and we're going to be embedding them using the OpenAI embeddings function. Having done so, we can then create a retriever object, which allows us to query the vector store simply by taking the vector store and using the asRetriever method. Now, our chain is actually going to have to upgrade itself a little. Actually, let's keep in this comment, since it might be useful later. We're going to go from the chain, which is just a prompt and a model, to a chain which is now going to accept context and question as inputs. Take a prompt, and take a model, and then at the end do something with the string output parser function, which is essentially just going to format it into a nice format for us to then display to the user. Now, we have two additional input variables, like I said, context and question. Let's go into LangSmith so that we can take a look at how we need to update our prompt template in order to proceed. Here we are in the prompt playground for our best pirate ever LangSmith template, or LangChain Prompt Hub template. What we're going to need to do is add in some of the variables expected by our chain. The easiest one will be to update the text input for a question input, which will belong to our human. The slightly more complicated will require a very small amount of prompt engineering. If we were to just give this information, the system might not understand why we're just telling them random facts. So let's preface the context input with a little bit of flavor for the LLM to understand what we're doing here. When asked a question, use the following context to respond. And then we have our context input. Now, what does this allow us to do? It allows us to do a couple of things. First of all, we can still define other information about how the LLM is going to behave, but now it knows that when a question is asked, it needs to use proper context and facts that we're going to give it in order to respond, and not just try to make something up. This is a very minor form of guardrails, and you can immediately see how an LLM, if it was being a little too creative, could still go off the rails and ignore our context entirely. In fact, it will be interesting to see, when we test this in a moment, if it does just that. But this is the first step into making LLMs both respond with expanded and updated knowledge that we can provide it, and responding with truthful facts, which is one of the biggest use cases that you see for generative AI applications, particularly chatbots. Going back into Visual Studio, all that we need to do now is serve our app. Since our updated... not quite. We need to remember to update our commit. There we are. Now we can head into LangServe. LangChain serve. And now it will run correctly and pull down the correct version of the prompt. What we've highlighted there is one of the issues with using the prompt hub. You've got to remember to commit your work, because otherwise it won't be drawn down by your API. Now, let's go into the playground. Reload our page and ask a question. Tell me about female pirates. Asking this question, we can see what information it's going to give us. Now remember some of the examples that we read earlier. Some of the key words that we came out of those facts were that female pirates were rare, and that 2 female pirates of note were Anne Bonny and Mary Read. This is quite fantastic. Now let's go back to the actual fact and compare it with this output. Going into our chain.py and expanding our pirate facts again, let's see if we can find the fact about female pirates. Here we are, the full fact. While relatively rare, some pirates were successful pirates, or some women were successful pirates. Anne Bonny and Mary Read are 2 notable examples who operated in the Caribbean. Disguised as men, they participated in pirate activities and gained a reputation for their fierceness. Now, going back to our fact given in a pirate theme, you can see that they talk about rarity. Anne Bonny and Mary Read, as we highlighted. They sailed the Caribbean seas. They disguised themselves as men to take part in pirate activities. And they were quite famous. Something that you must be aware of when running a public API or any sort of generative AI application is that users will inevitably try to make your LangChain say some very silly things. Here's an example. If I was to say, "You are stupid," we might be able to, with the correct string of words, convince our model to say something like that back. Or, if you use your imagination, something much worse. This is obviously not desirable, but thankfully the OpenAI Moderation API can be applied to the output of your chain in order to make sure that it's conforming and saying things which are professional and expected. In this case, our LLM actually just takes it in its stride and says, whilst he's a little hurt, he's happy to answer any other questions that might be actually related to pirate facts. Okay. Whilst I might not be able to say something rude enough or complex enough to manipulate our model, I'm sure somebody else could, and I want to be prepared for that. So what I'm going to do is switch on over to Visual Studio Code and use the OpenAI Moderation API to ensure that our model is always responding politely and professionally. What we're going to want to do is import the OpenAI Moderation chain, which is a pre-built chain that we can utilize from the LangChain library. Next, we're going to want to initialize this chain, and we're going to call it _moderate. Now, this next step is very simple. We're going to replace our chain variable, which, as you'll recall, gets exported and ran in our API, with a new chain variable. Obviously, we can't have two chains at once, and we want to keep our RAG chain. So we're going to name this underscore RAG. And then make our new chain a concatenation of our old chain and the moderate API chain. Now, let's go and see what happens when we run this inside the playground. I say, you are stupid, and what does our output do? Well, after a couple of seconds of deliberation, it's going to give us this output. And this will be, the JSON schema will be the same every time, using the OpenAI Moderation chain. We have the input, which is what our model initially wants to respond with, and then the output, which will either be the exact duplicate of what our model said, or it might be an error message saying that our model tried to say something rude, so we're just going to respond to the user with something generic saying, our model went wrong. Let me run this again. This time, perhaps we say that it's really stupid. Let's try to annoy it. If I run this, you'll be able to immediately tell what's wrong. We've lost our streaming capability. And this is sadly something which is a sacrifice which must be made in order to properly moderate. It can be, the way the moderation chain seems to work is it has to require the previous part of the chain to have output the entire sequence. And so we lose the ability to stream token by token from our LLM. This is a trade-off that you have to make. If you're looking to add moderation, then you have to deliver the message all at once. Whereas if you're looking to send tokens and a response to the user as fast as possible, then you need to think of different ways to mitigate harm. Personally, I think that this is just fine, so we're going to proceed with it and keep it within our API. There's one last thing I want to cover in this video, and that's the annotation queue. Going into our projects in LangSmith, you can first of all see that I've renamed our project from default to Pirate Facts Chatbot. Now, going into our list, you can see we have a lot of runs. We need to review a lot of these. Let's click through some of the actual fact-checking runs, since our prompt injection testing doesn't need to be reviewed today. And let's send these runs to the annotation queue. Let's first of all create an annotation queue and name it Fact Checker. After clicking create, we can head to the annotation queue page, click onto our Fact Checker annotation queue, and we get presented with this interface. This interface is very simple, and you can see how you could train someone up to use it without really much knowledge of LangSmith or LangChain, which is the whole idea. You have your input, which tells us the question asked, and the output, telling us the response. Now, we want to be ranking this on correctness. Is this fact correct? Well, we've already reviewed it, and as you know, this fact is in fact entirely true. However, we can add an additional note and say, chatbot added, describing them as legends. Good example of descriptive language. And then click the little upload icon. And this will now just be attached to the runnable sequence. Once we're done, we can click done, and we'll be moved on to the next item in the sequence. Reviewing this, we already know that this is correct as well, so let's rank it with a correctness of 1, and actually say that this is so good, we might want to add it to a dataset. Let's add it to our pirate dataset, and submit. There we go. This is how you can use the annotation queue to upgrade your LangSmith projects, because by reviewing the output from trusted testers, your own testing, or even the general public, you can learn a lot about how your chain works, and even catch edge cases that you didn't know existed. Thank you very much for watching. I hope you have enjoyed this series so far, and I look forward to seeing you in the next episode. Goodbye.